Hello, everyone. I'm Ginger from Iot Security. Welcome to today's webinar on realizing automated security for the industrial Internet of Things. With the increasing attacks on IoT devices, the IoT security issue has attracted attention. For this reason, cybersecurity compliance and certification for IoT equipment have become crucial and imperative for industrial development. What about the current status of IoT security certification? What are the key points that need to keep in mind before implementation? Our security CTO, Daniel Liu, will let us know the answer soon. During today's presentations, if you have any questions, please feel free to leave messages on the question board. Our speakers will definitely get back to you right after today's event. Now, let's welcome Daniel.
Hello, good afternoon, everyone. This is Daniel from Auto Security, and I am a CTO and a technical service department director, and I am in charge of security assessment service in Auto Security. And today it is very honored to be here to make a brief introduction about IoT security, and we will let you know what kind of enterprise product security and any international certification and regulation. And first of all, and according to the research, 50% IoT devices are currently vulnerable for medium or high severity attacks. And for those IoT vulnerability costs more than 500,000 per month. And you can see more and more open source library vulnerability information and malware attack IoT devices. And due to those vulnerability news and open source library issues, and some government and customer make the regulation and standard to act all the network connected devices need to meet the security requirement. So many device maker and manufacturer need to do something to protect their device and meet the security requirement from their customer requirement or to meet the regulation from some government. And I make a summary list about regulation and cybersecurity standard and industrial certificate on United States, Europe, and Japan. Like in United States, we have the SB327 on IoT devices, and EU also have their regulation for their IoT devices. We have the EU Cybersecurity Act, and in Japan we have the Telecommunication Business Act. And for different country and region, they have their regulation to act the IoT to meet the security requirement. And also we have a security standard or guidance like the FIP 140-3 and common criteria IEC C2443. And in Japan, we have the IoT security comprehensive countermeasure. And also we have some industrial certificate like the Ioxt and CTIA. And in Europe, some telecom company like Orange, BT, or some carrier company, they also have their security requirement. And in Japan, we have a CCDA certificate. And in the later slide, we will make the introduction about those regulations, standard, and certificate. And first of all, it's about the regulation and standard. And as you know, the EU Cybersecurity Act has been activated on June 2019. And there is a EU Cybersecurity Certification Framework in EU Cybersecurity Act, and it covering all ICT products, service, and process. And for each scheme, for certification scheme, they will specify one or more levels. For example, they may have some security certificate for the IoT devices, maybe for the consumer IoT devices, and they will be divided into 3 different levels, including basic, substantial, and high. And for each level, they may use or adopt some existing standard for those labels. For example, in basic label, they may use the ETSI EN303645 or CCEL2 as the standard for the basic label. And for the highest level, they may use X device to pass CCEL4 plus to meet the higher level. And I think in the near future, the more detail will be established for EU cybersecurity certification framework. Maybe they will more specific requirement for EU Cybersecurity Act. And in United States, there has a SB 327 for IoT devices. It has been activated on January 1st, 2020. And in SB 327, it asks all the IoT device then must use the unique password for each IoT devices, or the device need to implement a feature to require the user to generate the new password when they first log into the devices. And in Europe, there is an organization called ETSI. They also build a new standard called EN303645 for consumer IoT devices. So maybe more and more customers asking about the EN303645 about how their product to pass EN303645. So maybe I think in this year or next year, and ETSI EN303645 will adopt by more organization and need to as a device maker to meet this standard. And in United States, and there's an organization called FDA, and FDA also released the draft version about the cybersecurity in medical device in 2018. And currently, this is a draft version, not an official release. But according to our experience, some medical device maker has been requested to deliver the cybersecurity testing report when they submit the applicant for their devices. And some device makers did not attach the testing report when they submit the applicant. And FDA reject their applicant because they did not submit the testing report. So I think in the near future, and the FDA will ask all the device makers need to append the testing report for their device, and including how they make the whole device design and how they make sure their device is secure for their medical device. Okay. And in Japan, and the Ministry of Internal Affairs and Communication also released the comprehensive countermeasure for IoT device security in 2020. I think the most important part for this countermeasure is about the Telecommunication-Based Act will be amended because they put some security requirement for the Telecommunication Business Act, and all the endpoint device need to meet the security requirement. And for this requirement will be and has been activated by 2020. So many endpoint device need to meet the Telecommunication Business Act for the cybersecurity requirement. And the second part, we will make a short introduction about the cybersecurity certification. And first one is a common criteria. These are quite famous in cybersecurity. And in common criteria, they have 15 different kind of category of the product. And for each product, including the software, hardware, or chipset, and the device maker or chipset maker, you need to deliver a requirement to let the lab know what kind of things you did in a security requirement, and what kind of activity you adopt in the development, testing, production, and operation. In the whole software and product development life cycle, you need to do something for this product on cybersecurity. And this is for the common criteria. About cryptography, and NIST FIPS 140-3 also make a requirement for cryptography algorithm and the module. So you need to make the right implementation and protection on your devices and your cryptography module. Okay. And for IEC C2443 Part 4-2, and this standard is used for the ICS environment. For standard Part 4-2, they also have a requirement for the component, including the software, network devices, the PLC, and network devices. They have the requirement for those components. And for Part 4-1, they ask the device need to pass the SSDLC. And for Part 4-2, they have the 7 fundamental requirements for the devices. So you need to implement the authentication, and you need to make the confidential to protect the data, and also make sure your device can run secure in the ICS environment. Okay, and this is for the automotive security, the ISO 21434, and this define for this standard, it define the process to make sure the cybersecurity in automotive, and it can reduce the attack on automotive. And the first draft has been published in February 2020, and according to the ISO organization, they say the final standard may is released in mid of 2021. And I think in the near future, automotive security is more and more important, and they define a framework to make sure your device can run secure without a cybersecurity attack, because automotive is quite important because you sit in the car. So you don't want to see any kind of cybersecurity attack on your automotive, because it may affect your life. Okay, so for the automotive security, there is a new ISO standard called 12434, and they may release by this year or next year. And the third part is about the customer requirement and industrial certificate. And first of all, is about the Amazon Alexa service. And Amazon services are welcome any device maker use Alexa and cooperate with Amazon and use the Alexa Cloud to make a smart speaker or integrate the Alexa service into their product. But Amazon also requests all the device maker need to pass all the testing, including the functional testing, acoustic testing, and music testing. And most important one is about the security testing. So Amazon also asks all the device makers need to pass the security testing. And in the later session, the analyst from the Amazon security team will make a more detailed information about Amazon Alexa security testing. And for the IoT, there is a new alliance. They also build a certification scheme to make sure the device, all the IoT device, Android, and your mobile application is secure. They have a security pledge, including your password, interface, cryptography, and also about how you update your product. They make the certification scheme, and you can get the list of the certificate product on their website. And in North America, the CTIA also has their own IoT cybersecurity certification program. So if your device use some cellular network, so you can use a CTIA certification program to get the IoT certification. Okay, and in Japan, there is a CTDS, Connected Consumer Device Security Council. They also build their security requirement. Currently, they have 11 security requirement. So for automotive, the auto teller machine and test post machine, you can use list 11 a requirement to pass the certification for the CCDS. Okay, so since more and more security requirement from the government or regulation or customer requirement, so for the device maker, our security also summarize some critical factor for the product security. So the button, the red, the one is for the common, no matter what kind of the industrial you are. So you need to do a risk management. So I think the cybersecurity is not only for test. So you need to start cybersecurity from the beginning of your product design. So you need to do a risk management, and for any kind of network connected device, you also need to implement the software update mechanism. So no device will be secure forever. So you need to implement the mechanism to update your device, because someday there is a new vulnerability may affect on your devices. So you can use the software update mechanism to keep the user safe, because you can help your user to fix the vulnerability. And you need to use the unique password for each devices, and also implement the authentication for each security feature, and use the strong cryptography on any kind of connection and password and storage. And I think the most important part is about you need for every device maker, you need to implement the vulnerability reporting channel. So someone or some security research, they may find some vulnerability effect on your device. They can find a channel to let you know your device or your product have a vulnerability. So you can they can use this channel to let you know you have a new vulnerability, and you can use your internal procedure to research to make invest on this vulnerability, to see the R&D team how to fix this vulnerability and release a security patch for your product. And I think it's more and more important, because more and more requirement and regulation start to act. The device maker need to have a channel for the security researcher to reporting the vulnerability they found. And for each different industrial, like the consumer IoT, you also need to protect the user privacy, because sometimes for these consumer IoT devices, they may store their personal privacy. So you need to provide their protect the user privacy, and also you need to remove some hardware debug interface to prevent the user try to get some information or sensitive information from your devices. And for the ICS industries, and I think the most important is about the availability, because and for the ICS environment, they may use the device for a long time, maybe 10 years, 20 years, or 30 years. And all the device may need to make sure availability in their environment. They don't want to see any kind of attack on your device, and they may cause your environment cannot work anymore. So for the IC environment, you need to implement a security countermeasure to make sure the availability for your devices. And for everything you need, and you also need to implement the audit event. So in the future, there will be the cybersecurity attack, and for the investor, they can use the audit log to find out what kind of activity happened, and from which IP areas and when. And for the medical devices, and also private protection is quite important. But for the FDA requirement, they have some special requirement is about the software bill of material, because once your device released to the market, the FDA also acts a medical device maker. You need to continuous monitor for those software components, including the open source library you use in your product. You need to continuous to monitor for those library, whether is this the new vulnerability or not. If you find the new vulnerability, you need to release the patch or software update for your medical devices. And I think if you want to update your device, you need to build your Xbone to monitor your library to make sure there is no vulnerability exists on your library you use. And for the automotive, just I mentioned, the ISO 21434 may release this year or next year. And for this standard, they focus on the SSDLC. They have to make sure you have to do the full secure software development lifecycle to make sure you have identified all any kind of security attack may happen on the automotive, and you need also find a countermeasure to prevent this kind of cybersecurity threat. And not only in the testing and design phase, also in the operation phase, you need to find a way to make sure your device, your automotive can run secure and will not affect by some cybersecurity attacks. And this is all my slide. I hope those information about the cybersecurity regulation, standard, and industrial certificate information may helpful for all the attendees. Okay, thank you, everyone.
Thank you. Thanks for Daniel's sharing on all the IoT security regulations, standards, and industry certification. You may want to know more about device security for Elisa building products. It's our honor to have Amy with us today, the Principal Security Architect of Amazon Elisa Voice Service. Welcome, Amy.
All right, okay. Well, hello everyone. I am Amit Agrawal and I head security and privacy team for Alexa Voice Services. I'm excited to share with you today about what an Alexa built-in device is and what Amazon is doing to secure Alexa experience on your devices. Voice assistants are not just for the home anymore. We are enabling devices to be used on the go through headphones, car accessories, at hotels, businesses, and more. But we can't do it alone. AVS has been working to release hardware and development tools that make it easier for device manufacturers to build and release Alexa built-in devices. Today, there are more than 100 different AVS products and millions of AVS devices out there. There are also thousands of smart home devices that can be controlled by Alexa, making Alexa a centralized hub for the smart home. Today, Alexa is supported in 14 regions, which includes US, UK, Ireland, Canada, some countries in Europe like Germany, France, Spain, Italy, in Asia, specifically in India, also in Japan, Australia, and New Zealand. You can speak to Alexa in 8 languages, English, French, German, Hindi, Italian, Japanese, Portuguese, and Spanish. If you go and look out, just do a search of Alexa built-in devices, you'll see Alexa is present in a variety of voice control devices, starting from headless devices like speakers, headphones, smart screens, TVs, cars, PC, and smart home. And the way we enable these wide variety of devices is AVS provides SDKs, software development kits, to help accelerate your development with AVS APIs. These SDKs provide libraries that enable your device to process audio inputs and triggers, establish persistent connections with AVS, and handle additional Alexa interaction. I'm just going to, briefly mention 4 such software development kits. For example, starting with left, with AVS Device SDK, which we also call as AVS C++ SDK, you can create Alexa built-in product that connects your device to the AVS cloud and handles all AVS Alexa voice interactions. It's ideal for headless products like speakers, soundbars. With Alexa Smart Screen SDK, you can build screen-based products that complement the voice responses with rich visuals. The SDK itself also has, core rendering engine for Alexa presentation language, which helps with visuals. It includes support for televisions and smart screen experiences with partial panels and full screen panels as well. Then we have something for on the go, what we call as AMA, Alexa Mobile Accessory Kit. Using this kit, you can enable on-the-go voice experiences on Bluetooth audio devices that connect with Amazon Alexa app on Android and iOS smartphones. It is ideal for portable devices like headphones, Bluetooth speakers, hearables, and fitness devices. And finally, to the right is Alexa Auto Sdk, which you can integrate. You can use to integrate Alexa into in-vehicle infotainment systems. It includes a slightly different version of C++ source that auto OEMs or auto device makers can use to integrate Alexa experience. Also includes libraries, so your vehicle can process audio, establish persistent connections, and handle car-specific Alexa interactions. Before I go, I just wanted to remind everyone, if we were to go on developer.amazon.com and look for Alexa voice service requirements, you specifically see program requirements that requires developers must implement all reasonable security measures to ensure that no third party may gain unauthorized access to the Alexa service or AVS materials or any audio or content transmitted via this Alexa built-in product or any of its component. So as the Alexa built-in product selection grows and customers spend more time interacting with Alexa, we constantly look for opportunities to help you to enhance security of your devices. First thing we ask is, that you implement device security mechanisms to comply with minimum AVS security requirements. To help with that, what we have done is we have published these requirements on AVS developer portal, and these requirements apply to any device, to device actually built using any of the AVS SDKs, and it will help you, think about, device security mechanisms, overall how you want to implement it to improve the overall security posture. Number two, we do recognize, that Alexa built-in devices, they rely on complex embedded operating systems, like IoT devices, and there are multiple layers of application software, and a lot of that software comes through different supply chain. What you need to recognize is anytime you add a new service or a new feature to an existing fleet of devices, it introduces, there's a risk to introduce new vulnerabilities to the device. So therefore, it is important that you have a mature software maintenance strategy where you periodically patch vulnerabilities in software on your devices. And the way you can do this is you must start by evaluating potential threat scenarios by performing threat modeling for all the features and use cases for your device. Your software development lifecycle must include checks to evaluate if adequate authorization, authentication, and input sanitization mechanisms are being implemented for high risk or sensitive operations. To achieve that, we actually require that your devices must be built on components that are secure from hardware and software perspective both, and that they are actively maintained and supported by your suppliers. Also, I would encourage that you invest in vulnerability discovery and management, bug bounty, and incident response mechanisms. And last, number three, it is important to have, right security expert within your company to establish secure design practices. But it's also important to have an independent expert who performs regular security assessments on, production devices or prototypes, to have a look at it and then do a pen test on it. Specifically within the Alexa voice service program, we require device makers who build Alexa built-in devices to submit a security assessment report before Alexa services launched on that device. And every time there is a major change in device software or firmware, which may trigger recertification of the device itself. I understand securing devices requires a multifaceted approach in every step of the development process, from product initiation to design to launch. Even after launch, device must receive like security patches when the need arises. So some of the capabilities that I do want to make sure that you are aware of, like for example, secure boot. That's pretty important. It can be used to reduce the risk that a hacker can tamper with and gain a persistent foothold on the device. Secure key storage can be used to limit the exposure of authentication tokens, sensitive operations for attackers who have gained temporary access to the device. Crypto engines, hardware-based, preferably, can be used to reduce the risk of an attacker disrupting sensitive crypto operations, and also to ensure that, while the device is making those crypto operations, there is not a performance of, degradation on the device itself. This is actually a requirement for AVS device to use up-to-date operating systems with long-term support. It can reduce the risk of an attacker using old platform exploits to compromise a device. Host hardening can constrain the capabilities of an attacker targeting a device. You can consider using solutions like SE Linux or AppArmor to reduce the blast radius overall. Suppression of account privileges also can help reduce the risk of successful exploit of a service or process on the device. And then, threat surface reduction, which is basically removing unnecessary network services or, web servers running on the device, or, open ports that should have been closed on the production devices. It can simplify the whole hardening process and reduce the risk of an unneeded service being used to exploit a device. Last, but the most important one, I think I mentioned that in my previous slide, is to get an external pen testing, and especially for Alexa voice services and Alexa built-in devices, we specifically require a security assessment report from an AVS authorized security lab. So in 2019, Amazon authorized Onward Security Corporation's lab in Taipei as an authorized security lab for device testing and security assessment for Alexa built-in products. Onward offers these security assessment services, and in some cases where device makers want, a consulting service as well to ensure that their product meets AVS security requirements before Alexa services launched on those devices. In my opinion, Onward has like tons of experience in performing black, gray, and white box security assessment. That includes testing for network protocols, OTA security, hardware interface, denial of service, injection attacks, and we would also provide good guidance, really good guidance to the companies as they think about security incident response process, which is also very important. Onward Security is a valuable partner for Amazon and Alexa voice service. They're very professional with our developers during the security assessment process. I'd like to thank them for the excellent support. I also want to mention that last year, AVS security team authorized a couple of other Onward labs, specifically in Guangzhou, China, and then the newest one is in Tokyo, Japan. Before I leave, I'd like to share some resources which you can refer to later. Feel free to reach out to me if you have any question. I'd like to thank you for listening to me. I hope you have learned something new today. With that, thank you.
Thank you. Thank you, Amy. The Ioxt Alliance has been building security compliance programs for smart home, cellular IoT, and smart building markets. Now, here the Ioxt Alliance CTO Brad speak on the unique challenges faced by security organizations when building a security compliance program for commercial and industrial markets. Let's welcome Brad.
Hi there, everyone, and thank you. So I am the CTO of the Ioxt Alliance. We really are an organization focused on multiple markets, but tonight I'd like to actually talk a little bit more in depth about commercial IoT and some of the interesting issues around that specific market. But dropping way back, so who are we? We are an organization of a little over 350 member companies really focused on the smart home, smart building, cellular IoT, and mobile application market sectors. We were founded originally with core board members from companies such as Amazon and Google and Comcast and folks like this to really address the security or several perceived security issues in the consumer electronics space. So our goal was to really harmonize the standards that our leading manufacturers were using for their own companies, along with looking back and working closely with the regulations and regulators that Daniel was speaking about. So we originally launched with our Ioxt Security Pledge, and there's 8 core principles that tie into our pledge. But at the high level, it's really focused around security, upgradability, and transparency. And the reason that we really have these 3 pillars that we work around is in North America, we really saw a strong focus on device security coming out of NIST and organizations like that. While over in Europe, we saw a much deeper tie to consumer protection and a more consumer-centric view. And thus, we pull in several items around the transparency for IoT devices. And even as Amit was just talking about Alexa services being embedded everywhere, as more and more consumers are wearing wearables or having microphones everywhere. As a matter of fact, my glasses happen to be Alexa enabled. And I could tell you that absolutely consumer concerns around security and privacy are absolutely real. And this is where the Ioxt Alliance has really stepped in to try to provide harmonized guidelines across a global region so that consumers can have confidence in the products that they're buying and ultimately increase the rate of adoption. So the problem is with IoT, there's a lot of things. So we started out with our base profile, which I'll show in just a second here. But then what we've done is we've really taken an approach where we look at specific markets or devices and we define further security profiles for those markets or devices. We do this based on a threat assessment where we start out really looking at the beginning of life of the device at the factory, going all the way through the supply chain, distribution, provisioning of the device, operation, and then ultimately even ending at the end of life of the device and reverse logistics for products that may get returned back into the stores and how we can guarantee that consumer private data maintains private in those, yet still can be put back on the shelf or resold through secondary markets. So before I get into the specifics around commercial issues, I'd like to talk about just our base profile and really how this profile is put together and how it ties back to a lot of the regulations that Daniel was talking about earlier. So the way this chart is really read is for each of our 8 core principles, from no universal passwords through verified software and security expiration dates, we have a minimum that every device needs to meet. So that minimum is shown here with the yellow arrows. However, our top line goal was to really mitigate large scale remote attacks. Essentially, a lot of the regulations that were really being discussed were caused because of the Mirai botnet attack, or at least that was the original shot across the bow for many of the regulators, many of the legislators who were looking at potential attacks that could come across the internet from consumer gear. However, we didn't want to just stop at the baseline, but we also didn't want to set the bar too high. So the approach that we really took is on the secured interfaces is a great example. Our baseline, this SI1, is really about protecting the device against remote attacks. But then we take a step further and we define, well, what would attacks look like for proximity? And what would those attacks, what countermeasures would be needed, what mitigation should be there, and then how can we verify that these mitigations were implemented? And then finally, we provide guidelines for what would countermeasures look like for physical attacks. Now, once again, based on the type of product that you may be doing, for baseline, remote attack may be strong enough protection. But we absolutely wanted to create a way for manufacturers to compete on security, to bring it from a liability and overhead to a feature that can be proudly displayed on boxes and let consumers know what they're getting, provide that transparency, and provide a way for people to do more. Now, the baseline profile was good for a peer base, but then what we ended up really looking at was some devices carry significantly higher risk if there's attacks. So one of the first profiles that we've launched is a residential camera profile. So once again, these cameras, I've got a couple different examples of the type of cameras that we're looking at. Things such as traditional Wi-Fi cameras, but then even doorbell cameras that may be on a more constrained power budget and things like that, or even cameras that are running non-IP protocols over to an IP base. But the important thing that you'll notice in this is if you look at the base and secured interfaces to the camera profile, there's a significantly higher set of test requirements that got added. Further, as many of these devices are IP, we wanted to make sure that the devices are not only protected from remote attacks, but the very common proximity attacks. Since these are going to be sharing the network with either the home, the business, or a potentially an operation style network, we wanted to make sure that cameras on these networks are protected from other devices, along with providing protections to the other devices on the network. Further, what we really recognize as we work through these profiles, though, is that there are certain things that consumers are very concerned about in ways of their privacy and things like that. So staying again in the secured interfaces space, we've built in protections really around protecting the data that's stored in the cloud, along with even high-level goals such as having account keys, which are rotated and blind to the manufacturer. So the consumer knows that only they have the keys to be able to view their data. Now, once again, those higher level requirements are not required for certification, but provide that roadmap, provide the guidance on what great security would look like. Now, with that as a backdrop, I'd like to talk about the challenges of commercial IoT. So, as I mentioned, the Ioxt Alliance's second market that we are very focused in is smart buildings. This really started out with many of the smart home manufacturers who produce connected light bulbs and light switches also happen to have commercial thermostats, commercial lighting systems, and things like that. Now, there's several core challenges with these commercial systems. And what I'm showing here is a pretty typical example of a HVAC, a heating and air conditioning system that many of our member companies produce. These systems include things up in the cloud that can monitor usage, provide full multi-campus visibility. But then these cloud services also very often have to run on premise. After all, if the internet goes down, you want to make sure that your lights still work. The other challenge with these systems is the number of high capability control points scattered throughout a building. So this middle layer are basically controllers that would control entire floors, small buildings, and things like this. They're typically Linux-based platforms and have a decent amount of horsepower and everything, and connect to a operational network. Now, the challenge with these is that operational network has to be protected from the rest of the building. These devices do need to be able to withstand 20 years down the road if a maintenance person accidentally plugs in an Ethernet jack and connects the operational network to the building network. Further, these devices provide gateways between an IP, traditionally enterprise class network, down into much more constrained devices that are either running IP protocols or protocols over RS-45 and twisted pairs and things like this. And these devices happen to be more microcontroller based, tend to look like thermostats and light switches and ballast controllers and these types of things. So overall, what Ioxt really has looked at here is how do we provide that baseline security, but then take our profiles and build upon these different layers. So this is some of the stuff that we're working on right now. But I want to hop back to the much larger concerns when you're thinking about IoT security. And in reality, there's I'd like you to put on one of two hats. Probably some of you are manufacturers who are building into this, or there's others of you who are the integrators or the folks who have to buy this equipment and deploy it in a secure manner. Now, consumer electronics has relatively short lifetimes, typically maybe 3 years or something like that. But these commercial systems have the challenge of being deployed 10, 20 plus years. They typically get built in behind the walls, in the ceiling, very difficult to upgrade. Further, they have to have high reliability. So it's not just security, but reliability goes hand in hand with these things. Because at the end of the day, the cost of failure is significant. If someone can come in and hack and turn off the lighting system for a large office complex or building, basically you could shut down the productivity of all the companies in there. The other really interesting challenge in commercial IoT is the whole multi-tenant problem. So one interesting thing as these systems are deployed is very often they're going in before the internet shows up. So a lot of these guys talk about they've been doing IoT for the longest time, but once again, the I is optional. So you can't build authentication systems that require cloud connectivity all the time. Beyond that, those installers typically have a low set of tools that they're working with. They have to be able to configure the system and hand over the system to the building owner, who then leases out portions of the building to the business owners, and ultimately portions of those are occupied by different employees. So unlike a smart light bulb where you may just have the user is the administrator, you've got this much deeper complex system of rights that you have to be able to manage in such a way and rotate credentials over the 20-year life of this. The other real interesting challenge of this is, as I mentioned, a lot of these things use old serial communications. They have very old legacy protocols that have to be able to run. These protocols may reach from the cloud down, so they have to be encapsulated in such a way that they can be carried, but ultimately have a limit in scope. So as I mentioned, putting on two different hats, like to just touch on a little bit of what should you do. For the manufacturers, what I really highly recommend, and you've heard Amit talk about this too, it's very critical to get third-party assessment. So organizations like Onward provide great pen testing across either a multitude of security standards. They also happen to be an Ioxt authorized lab, and I highly encourage manufacturers to take their devices through the Ioxt security standard as it ultimately maps back to several of those regulations. But having a third party take a fresh set of eyes at the product provides a great insight and provides extra assurance that things are truly implemented as they should be. The other thing that's interesting, as the Ioxt Alliance has focused originally on devices and now working on mobile applications, one thing that we've seen is device companies have been doing great security for a while, but very often the mobile applications have some extra challenges. A lot of times these may be developed with multiple third-party libraries. The code supply chain may be deeper. And once again, having third-party assessment is a very valuable tool. And as Daniel was talking about at the beginning of this presentation, the number of regulations are large. They are continually growing, and I highly recommend getting engaged in organizations that can provide that visibility. A couple of the other things I really like to say is security has to start at the beginning of the device and go all the way through the life cycle. Great security requires great processes. It has to be part of the culture of the engineers. You can't just apply security at the end and get the results that you want. Now, on the flip side, the interesting question comes, until you can buy Ioxt certified equipment or others, what should you do? So when this is posed to me, I really suggest one of the first things, if you're building or deploying a large network, very first simple thing is ask your vendor, what security standards do they follow and how do they validate these issues? And typically that question right there cuts to the chase right away. If a company is not able to tell you what processes and standards they follow, then it's probably not in that culture that I mentioned. Another really telling thing that you should look for is how often do software patches get deployed? So not only should devices actually have firmware updates, but many companies who don't have security as part of their culture, they will launch a device, rotate the engineering team to a new device, and that old device never sees a single update in the life of the device. Once again, if a company isn't willing to invest and maintain the devices, where do you think you'll be in 20 years with that company? I also highly recommend joining organizations such as the Ioxt Alliance to really hear what your peers are saying. Get involved in what into the security discussions. Hear what other challenges other companies are having and how they're addressing this. And finally, a last couple things. For now, I highly recommend, as much as possible, limit the scope that your IoT devices can reach. So if your devices can run on VLANs, can be separated from enterprise networks and things like that, it's just best so that if something does go wrong, it can't spread across your network. And then finally, make sure that you have monitoring put in place. Make sure that you have a maintenance program set up with your devices. Make sure that your manufacturers are actively informing you when they have software being pushed out. So finally, I'd like to talk a little bit more about the Ioxt Alliance. As I mentioned, we've got a little over 350 companies. These companies range from device manufacturers to service providers, network operators, ecosystem operators, and retail channels, installers, and folks like this. basically there's a home for everyone in the entire supply chain. We've got several different activities that are open to all members. And these things include monthly member meetings where we bring in some of the regulators, we bring in some folks to talk about some of the challenges and new things on the horizon. We also, as I mentioned, have been very close with public policy. Our public policy awareness work group is an organization where, same thing, we bring in the regulators into a small forum, have them talk about what they're trying to do, and have roundtable discussions to share back what industry is trying to do and how we can work together. A couple of the other interesting work groups that I would highly recommend is our compliance work group, that is really the meat and potatoes of where the security standards and testing standards are being discussed. And finally, we've got a building controls work group. This work group is really focused on looking at what are the challenges to deploy smart building systems? How can we connect securely lighting systems to HVAC systems to access control to fire and emergency and security systems? So once again, if you're interested, please go out to our website, and we'd love to have you join our alliance. And with that, thank you so much.
Thank you so much, Bray. Before today's final presentation, please know that you're going to have a chance to try our automatic product security assessment platform for free, or a special coupon for the Ioxt cybersecurity testing, as long as you filled out the questionnaire that will pop up on your screen after finish today's webinar. Now, our security sales manager, Tano, is going to share IoT security trends and AI automated product security solutions with us. Welcome, Tano-san.
Hello, I'm Tano from Iot Security. Today, I will share with you two topics, the IoT security trends and AI automated product security solutions. Today's presentation will help you understand the market status, especially in US and Japan, and how you could improve product securities. In the beginning of this session, let me introduce the market status, like regulations and the details of actual incident recently happened. Enacting the laws. First one, IoT Cybersecurity Improvement Act of 2020. It's formulated by US government. This federal law is dedicated for IoT devices, which means US federal government and connected to its system should follow the security standards. Meanwhile, products have a plan to selling in US, especially selling to government section like binding items should follow these security standards. Second one, Telecommunication Business Act. It has fixed by Japan government in last year. Due to the IoT targeted cybersecurity has been increasing, Japan government newly added 3 types of requirements for manufacturers. So let me introduce the details. Requirements 1 should be any kind of ACL, like access control list featured in the device. And the second should be set the unique password for each device or any kind of automatically change password in the first setup phase. And the third one should be software update feature. Or this way is more easier way to follow maybe. The device was already obtained at CC, the Common Criteria certifications. According to Gartner, over 80% of organizations currently use IoT devices to solve business use cases, and almost 20% of organizations have already detected an IoT-based cyber attack in the past 3 years. In the left part of this presentation, Report 20, it is the collective group of vulnerabilities in a widely used TCP/IP software library developed by Track Incorporated. This software library widely used for industrial devices like power grids, medical device, home device, networking device, involving a diverse group of vendors such as HP, Intel, Cisco, Mitsubishi, etc. Next, let me introduce another big vulnerability which found in end of last year. It's called Amnesia 33. It's a set of 33 vulnerabilities that are caused by TCP/IP stacks like UIP, FNet, Pico TCP, and NATNet, which importantly serves as the fundamental component of millions of connected devices. And these two widely affected vulnerabilities cause three types of problems, like denial of service, data breach, arbitrary code execution. Okay, from the next page, let you know how our existing customer has been corresponding this kind of threat. First of all, I picked out several customers, like D-Link is famous network device manufacturer based in Taiwan, and also ASUS has been implementing their security product called SecDevice for internal testing. SoftBank is enterprise telecommunication company based in Japan. They use our SecDevice to scanning the network equipment by project. Okay, finally, I have an opportunity to share with you our security product. When companies start to study about product information security, you will often find the keywords like SSDLC, Secure Software Development Lifecycle. Let's look at the world. Most famous company who implement SSDLC is Microsoft. They already SSDLC be a basic policy of their development scheme. In the SSDLC, totally define 6 steps. Unfortunately, because time is limited for my today's session, I couldn't introduce the details of SecFlow. SecFlow is our security management tool which can assist you to implement each step of SSDLC, like define the security requirements, threat model management, vulnerability scan, which means doing a static scan for source code, etc. Next step should be security test. In this period, you must use our SecDevice. And SecDevice provides following feature that says your security test, like unknown vulnerability scan. Generally, it's called fuzzing. And of course, you can do a non-vulnerability scan and wire scan support Wi-Fi communications. Also have web application scanning supported. Okay, now everyone know how you could do a non-vulnerability scan, but maybe someone don't know what is fuzzing. How you could find unknown vulnerabilities. So what is fuzzing? It's a type of black box testing. Use a huge set of test patterns to simulate the invalid or unexpected status. When device fails or returns an abnormal state, it will be a problem. Yes, it means device contains unknown vulnerabilities. This type of testing called robustness test and hardening. When vendor found faster than attackers, it's lucky, but if hacker found first, it will be zero-day attack. Nowadays, manufacturers not only against this kind of attacks, but also should comply for requests from market. Why you should implement product information security? Most of the manufacturers have a pressure from external reasons. For example, several upstream request security testing for delivery condition. And also, open source software is expanding your development flexibility, but it always latently contains known or even unknown vulnerabilities. And so on, compliance meaning in the beginning of this session, I have introduced about US government law for IoT devices and telecommunication law in Japan. And lastly, the company tends to obtain certification or authorization for industrial standards like IEC 62443 for industrial control system security and ISO 2701 for information security? And in this situation, what you should do? The answer is automation. AI automated product security solution, IoT or IIoT, that is industrial IoT, manufacturer is to use our solution. Based on feedback from our existing users, there are 3 types of problems that they constantly encounter. As I mentioned before, 20% of organizations have already detected an IoT-based cyber attack in the past 3 years. Security engineers are more difficult to seek than developers. Meanwhile, in-house security is difficult to achieve. Actually, other companies provide fuzzing tools but they only provide limited features with higher cost. And the method of automated product security solution, it means the same as method of SIG device. Firstly, we focus on our user experience. That meaning most of the testing flow has already automated, even setting the parameter of fuzz patterns. And this is our unique point. We already obtained a patent for an algorithm of fuzz pattern creation that can reduce the test time and improve the test accuracy. Secondly, SIG device has a simple interface and it supports multi-language like English, Chinese, and also Japanese. And thirdly, you can reduce the time and human resource for testing. Okay, let me introduce the details of SIG device. SIG device provides these 6 types of test features, which depends on your package license. For example, like fuzzing package provides protocol-based fuzzing tests, and the vulnerability package includes non-vulnerability scan and backdoor scan. Web package provides web application testing and DOS testing. And these sort of testing items has already required by these 3 types of industrial standards, which are OWASP Top 10 for web application security and OWASP IoT Top 10 for IoT security, and also IEC 62443 Part 4-2 for industrial control system security. So now let's break down to each test feature actually can do what. So first, I will introduce backdoor scan. Maybe you know what is the backdoor, but it comes with different types of situations. Like backdoor comes from website. When you visit unsafe website, you will get a malicious program on your computer. In these cases, the owner of website should provide security with a secure website access. Meanwhile, website owner can use SIG devices with application scanning to ensure the safety. Next, it's very easy to happen is missing in development phase. If you are a developer, you will open some port for maintenance or development purpose. Unfortunately, someone forgot to close this port before a product had launched. And lastly, it's known that hackers use known vulnerabilities. Next, SIG devices with application tests can execute OWASP Web Top 10 categories. Based on our experience, most of the users easy to find like a SQL injection, command injection, cross-site scripting, and misconfigurations. Okay. Detected unknown and known vulnerabilities. The number one is Amnesia 33, and second one is Report 20. And these two benefits were already introduced in previous page, so I will skip those. And the third one is called SummerCry, taken from the SummerCry website. SummerCry has exists in code for a long time, but has not been discovered until 2017. It is a bug introduced at this design level, allowing Samba. Samba is the software that enables to use the SMB CIFS protocols and communicate with Windows-based server to share the files and printers. And the last one, called Suite 32, is open. It's based on the OpenSSL. And OpenSSL could allow a remote attacker to obtain sensitive information caused by an error in the DES and the EDS chipper used as a part of SSL TLS protocols. In this page, I will introduce which protocols supported by SIG device fuzzing tests. For the core network, of course, support like IPv4, IPv6, TCP, UDP, or several protocol you have probably heard before. Quite amusing point is SIG device support SNMP trap. It is especially used in the industrial products and ICT device for management purpose. In the category of IoT, like BACnet, used for smart building management, Modbus, Profinet, Ethernet IP, and CIP is for PLC, like a programmable logic controller, and CoAP and MQTT is now frequently used in between IoT sensor and service communications. At last, in the healthcare industry, like FDA US announced the guideline for medical device. In that guideline requirement, it requires robustness testing for specific medical devices. Thus, if you are a medical device vendor, you must do the fuzzing test. Okay, let me quickly go through SIG device features. And the first, comprehensive test case and supported device. As I mentioned, SIG device has not only provide fuzzing tests, but also provide non-vulnerability scan and web application scan. Generally, this kind of feature separately provided by multi-vendor. It means you waste time and pay more money. And the second, it's very easy to use. SIG device provides intuitive interface, and you can finish the whole test in only few steps. The third one is workflow testing report. SIG device has a report exporting feature. In the developer report, it has a detailed information for status and how you can fix that issues. Okay, in the last of my session, let me introduce 3 case studies. And the case study 1 is case study of Taiwan-based network device manufacturers. Due to they don't implement secure development life cycle (SSDLC), vendor had appealed by FTC, is a Federal Trade Commission in US. Afterwards, they agreed to change the development policy to settle with FTC requirements. And they will set these 3 levels of testing phase. And testing phase 1, execute and do the black box test by SIG device. And the level 2, do the fuzzing test by SIG device. And lastly, concealing the product penetration test for third-party labs. So actually, it's concealing for us. Afterwards, they provide us this kind of a feedback for us. And 1 is sharply accumulated the testing know-how in the QA teams, and also only spent 2 months to set up a security dedicated team. The next case study is IoT, Industrial IoT Device Manufacturers one. IEC 62443 Part 4-1 is now very popular in the industry, and it is officially announced in 2018. Actually, the part of Part 4-1 is a part of standard for secure product development lifecycle requirements. Most of the related manufacturers have studied how to comply this. In the Part 4-1 requirement, it has obviously required the SSDLC, and plus SIG device can assist the 1/3 of test case which defined in the IEC 62443 Part 4-1, and only spend 3 months to prepare the response ability which can fulfill requirements. During the preparation, use SIG device to reduce the resources. Okay, let me introduce someone. This is for healthcare device manufacturers. As you can see, product security is the most important element in the healthcare industry. Pre-market approval 510K for medical devices was officially announced by FDA in 2018. In order to regularly sell or distribute medical devices in the US, manufacturers must obtain approval. Moreover, this guideline is commonly referenced by other countries' laws or regulations. And these requirements obviously define a robustness test is same as fuzzing test for medical devices. And also, SIG device can execute 70 types of fuzzing tests for Wi-Fi communications. Not only in this healthcare industry, I think product security is common challenges of each manufacturers. Even if manufacturers only hire traditional QA or QC engineer, you can execute fuzzing tests by SIG device accordingly. So if you have any challenges, please just try SIG device. Okay, so my session is all. Thank you all for listening. It was a pleasure to be here today. Thank you.
Thank you, Tano. If you have any questions for our speakers, please leave messages on the question board, and we will get back to you right after the event. Thanks again for your participation today. Please help fill out the questionnaire later to win the lucky draw. We look forward to seeing you next time. Thank you.